Understanding biochar. Biochar is produced after pyrolysis of biomass, typically within a temperature range of 300 degrees centigrade to 800 degrees centigrade. Biochar formed within this range is the most valuable. At relatively lower temperatures, a higher percentage of the biomass gets converted into biochar. At higher temperatures, some part of the biomass is converted into energy, producing less quantity of biochar. As such, the design of the pyrolysis kiln or retort is important in determining temperature range and biomass to biochar conversion efficiency. In rural areas where biochar is simply the end product left behind after meals, have been prepared on biomass cook stoves. Stove design determines the rate of energy generated. Biochar and ash produced as byproducts in the process. I have designed over 50 biomass cook stoves based on materials available in rural sites. With its higher efficiency, a typical good stove reduces biomass fuel consumption and produces 16% to 25% biochar of the original biomass used as fuel by weight. Say I have used a biomass with about 15% moisture of 100 kg for cooking needs. At the end, I could have around 16 kg to 25 kg of biochar. Research has shown that the benefits of biochar include improvements in soil productivity, long-term carbon sequestration, reduction in greenhouse gases emissions, and reduction in loss of nutrients by leaching. Biochar is known to have high cation and anion exchange capacity and adsorption as well as absorption, which improves nutrient use efficiency when biochar is applied to the soil. Biochar is particularly beneficial in sandy soils and highly weathered clay soils with low native cation exchange capacity and anion exchange capacity and low fertility. Biochar also acts as a source of small amounts of phosphorus, potassium, and other nutrients. Soil pH is an important factor in determining the bioavailability of nutrients, and biochar is known to raise soil pH, thereby improving the availability of nutrients to crop plants. Biochar compost has a very high soil microbial density, which balances and brings the soil pH close to neutral over a period of time. Biochar compost can be applied to all types of soils, acidic, basic, and neutral soils. It has been reported to absorb and adsorb harmful chemical compounds from the soil, such as phytotoxins and nitrification inhibitors, and improve plant growth. Biochar is also reported to enhance microbial population and improve moisture holding capacity and soil structure. In the wake of raising carbon dioxide concentrations in the atmosphere and global climate change, biochar's resistance to decomposition offers another ecological benefit. Biochar can remain in the soil for extensive periods of time from hundreds of years to millennia. reported that the terra preta soils contain up to 70 times more carbon than neighboring soils. Radiocarbon dating of the soil show biochar dating back from 740 to 2460 years. Research has shown reductions in greenhouse gas emissions and reduced loss of nutrients due to leaching when biochar is used as a soil amendment, which adds further incentive for its use.